Okay, this is a free response calculator active problem that we're allowed 15 minutes for. Sometimes we call these calculator permitted or required. And we have condition 1. Let g be the function given by g of x equals x cubed minus 3x squared minus 2. A, write an equation of the line tangent to the graph of g at point 1 comma negative 4. And then B and C. Let's go work on A first. Write an equation of the line tangent to the graph of G. Well, to find, we'll work on A first. I'm going to put A right over here to the right. To work on A, we need two things to find the equation of tangent line. We need first a point, and our test writer was kind enough to supply that point in its entirety. So our point is 1 comma negative 4. And the second thing we're going to need is a slope, which we're going to call m sub t. And to find the slope, we're going to need to take the first derivative of this function here. So we'll say g prime of x, which is the first derivative, is equal to 3x squared minus 2 times 3 minus 6x, and the derivative of negative 2 is 0. So to find the slope at this point, we're going to need to substitute our 1 in for x. So we have g prime of 1, which is equal to, write a little more, g prime of 1, which is equal to 3 times 1 squared minus 6 times 1, which equals 3 minus 6, which equals negative 3. So m sub t equals negative 3. Now we have all we need to write the equation of this tangent line. And the tangent line is in point slope form. Y minus y sub 1, or y1, is going to be y minus negative 4, which is going to be y plus 4, equals m, which is our slope, negative 3, times x minus x1. And so this is going to be our answer to part A. Okay, let's go on to part B. Part B, find the absolute maximum value of g of x on the interval, the closed interval, negative 1 to 1. Show the analysis that leads to your conclusion. And I think this is the one that really, I don't know if we really need a calculator for this problem, but I think when you look at absolute maximums making a test, a calculator really helps to be able to plug in values. So let's go ahead and, well, first of all, what do we need to find an absolute maximum? Well, we're going to need to do what we call a candidate test. And as candidates, we are always going to have our endpoints. And our endpoints in the interval, we have x and g of x. Our endpoints are going to be negative 1 and 1, and then any extrema in between. So for B, let's take, we have this function g prime of x equals 3x squared minus 6x. Now to find critical points, we're going to set this first derivative equals 0. So 0 equals 3x squared minus 6x. And we can factor out, I think, 3x from both of these things here. So we have 3x times quantity x minus, what do we multiply times 3x to equal negative 6x? I think it's going to be negative 2. So for this, we're going to have our critical numbers And using zero factor property, we're going to have 3x equals 0. So therefore, x equals 0 is one of our critical numbers. And also we can set the second factor, x minus 2 equals 0. And that will give us a critical number of x equals 2. And so, let's see here. Let's take, we can do a number line to find our analysis here. We have 0 and 2. But are we really worried about 2? No, we're not, because of this interval we're dealing with over on the right here, 2. We're interested in just -1, because 2 is outside this interval that we are evaluating. So we're going to take G prime and above this line and G below, and we're going to use this function right here to find and plug in what's a number less than no, I got it wrong here, guys. Our critical numbers are 0 and 2. Okay, 0. To the left of 0, we can take maybe -1. If we substitute -1, we're going to get a negative for this term here, and then -1 minus 2, that's going to be negative times a negative. So G prime is going to be positive in this interval here. And to the right of 0, we can take 1. We're going to have 1 substitute here to the left, 1, 3x would be positive, and 1 minus 2, that's going to be negative. We're going to be going down. So what does this tell us? This tells us probably our best candidate, maybe our only candidate, is going to be at 0, because we see that -1 is going to be less than this maximum, relative maximum at x equals 0, and also 1 is going to be less than. So we're probably going to be dealing with just this. Now what we're going to do is go to our calculator, and I previously had done that, and here's the graph of the function. If you go to the calculator, we see if we enter the function which was the original function, which is this one here, g of x equals x cubed minus 3x squared minus 2, we see our endpoints, -6, at 0 we have -2, and at 1 we have -4. So what that does is, going to our candidate test, we have -6, -2, and -4. So this one is right here, our absolute max equals -2. And what happens is, as far as justifying, show the analysis, what happens this candidate test, and the only thing I'm going to label this is candidate test, qualifies as analysis that leads to conclusion. Now lastly, we're going to find the x-coordinate of each point of inflection on the graph of fx, and to do that we're going to take what we call the second derivative of this function. So I'm going to work part C over here to the right. I think we have enough room here. So we have, for part C, we're going to have g double prime of x is equal to, let's see, the first derivative of g prime of x equals the second derivative of g of x. So we're going to have 6x minus 6. And to find our point of inflection, or possible point of inflection, we set the second derivative equal to 0. So we put 0 equals 6x minus 6. And we can factor out a 6. So 6 times 20x minus 1. So we have divide by 6, divide by 6. We have 0 equals x minus 1. So solving for x, we have x equals 1. So x equals 1 is our positive point inflection. I'm going to draw this number line here in green, and 1. I'll put g double prime here on the top, and g below. This is 1 right here. And we're going to use this function here. I think 0 equals x minus 1. We can just use this one. Let me write it more clearly here. 0 equals x minus 1. There we go. And if we take a number less than 1, say 0, well, we're going to have negative or concave down, right? And then greater than 1, say 2, we have 2 minus 1, we have positive. And so we would go ahead and state it this way, justify your answer. There is a point of inflection at x equals 1 because at x equals 1, g double prime of x changes from negative to positive. So that is our answer. Let's see here. So we have answered A, here this equation, B, which is absolute maximum, equals -2, and C, the point of inflection at x equals 1. So this should be helpful to you, and I thank you for viewing. Bye.